Adding two fractions together? You've done that 100 times. Common denominator and two neat little fractions collapse into one. Today, we run that whole thing in reverse. You're handed the single, ugly fraction, and your job is to prise it back apart into the simple pieces it came from. That backwards trip, that's the entire idea here. So here's the move, and when you're allowed to make it. If the bottom factorizes into two different linear brackets, the whole fraction splits, one piece for each bracket. And sitting on top of each, a constant nobody's handed you yet. Call them A and B. Pinning down those two numbers is the entire job, and it's got a name: splitting into partial fractions. It's worth the effort too. This is the trick that makes integration and binomial expansions behave later on. So let's earn it on a real one. This single fraction, and notice, the bottom is already split into two different brackets. That's exactly our green light. We want to rewrite it as something over x minus 3, plus something over x plus 1. And we're asked to do it twice, first by substitution, then by equating coefficients. Same answer, two different roots there. Both methods start the same way. Put a over the first bracket, b over the second, and add them back over a common denominator. Now look, the bottoms on each side are identical, and if two equal fractions share a bottom, their tops must match too. So it all comes down to the numerators. 6x minus 2 equals a times x plus 1 plus b times x minus 3. And that 3-bar sign? It means an identity, true for every value of x. That one tiny fact does all the heavy lifting. Here's the sneaky part. Because it's true for every x, we are allowed to just pick one. And we pick the value that makes life easiest. Let x be 3. Now watch the b term carefully. X minus 3 turns into 0. And the whole b piece simply vanishes. The left side becomes 16. The right is 4 lots of a, so a has to be 4. That's one of them down. Now, the mirror image. This time we are after b, so we knock out a instead. Let x be minus 1. The x plus 1 bracket collapses to 0, a disappears, and only b is left standing. The left side, minus 8. The right side, minus 4b. So b is 2. And that is both constants found. Slot the 4 and the 2 back into their places, and our single, ugly fraction has split into two clean little pieces. The hard thing, made easy. So that was substitution. Fast, almost cheeky. But there's a second route, and it's the one that always works, even when no clever x can rescue you. Same opening line. 6x minus 2 equals a times x plus 1, plus b times x minus 3. Only this time, instead of choosing an x, we just expand it. Multiply it all out, then gather the terms. Every x in one pile, every plain number in another. And the right side turns into a plus b, lots of x, plus the bundle, a minus 3b. Now compare the two sides, piece by piece. On the left, x carries a 6 in front. On the right, it carries a plus b. They have to be the same number, so a plus b is 6. Do the plain numbers the same way. A minus 3b is minus 2. Two equations, two unknowns. Subtract one from the other and the a's cancel. 4b equals 8, so b is 2. Feed that back in, and a is 4. Exactly what substitution gave us. 2 roads, 1 destination. So which method do you actually reach for? Substitution is quick, the moment you can choose an x that zeroes out a bracket. And here, you could, twice over. Equating coefficients is the workhorse. A little slower, but it never lets you down, and it makes a lovely check when you want to be certain. Either way, the recipe doesn't change. Factor the bottom, write a constant over each piece, then go hunting for those constants. Get really comfortable with this one now. because once integration and binomial expansions come along, you'll be splitting fractions like this without even thinking about it.